Okay, so this is what we refer to as a focus activity, and you'll notice these are going to be numbered. You might get one or two of these a week, definitely not every day, and it's also labeled by 6 weeks, so we'll be able to tell exactly, when these took place. But these are another opportunity for you guys to just get a really easy grade, and all you got to do is just work it. You turn it in when I go ahead and ask you to. So I like to do 2 sets of these at 6 weeks. For this first one, I'm probably going to go ahead and go to 3. So I'm thinking you'll get the next one on Friday, probably the other one early next week, and then I'll go ahead and have you turn them in. But we are going to go ahead and work these together. It's just a way to go ahead and start the class, kind of something for you to just go ahead and focus on, maybe if we don't have anything else going on that day. At the beginning of class anyway. But I want to encourage you, don't wait until I come up and say, okay, let's go ahead and work through the problem. Try to work the problem yourself, because maybe it could be review on current material we're looking at. Maybe it's something that I just want to go ahead and bring up we haven't seen in a while, or maybe I just want to use that time to go ahead and quickly introduce you to a topic I don't want to spend an entire class period on. Okay, but we work them together. We're going to go ahead and turn them in, and we do them by sets. Bless you. So let's say if, next week when I say, okay, we're going to turn them in on whatever day, we have 3, you turn in 3 out of 3, what are you going to get? 100, as long as they're worked. Okay, we're going to work them together. Okay, I encourage you to try them on your own, okay, but we are going to work them together. Now, if you turn in 2 out of 3, okay, well then what's 2/3? 67. So it really depends on how many we have in the set. Now, any extras I have, I'm going to put right over here in the pockets on the door. Okay. And I'm going to leave them up, until the day that we go ahead and turn them in. So if you ever lose or misplace it, definitely come on over and grab another one. But once the extra copies are gone, that's all I got. Okay, so really all you have to do is follow along. You keep up with these, put these in your binder folder wherever they are safe, and you just turn them in when I ask. You're good. I'm going to make that a 100 quiz grade, okay, or whatever other grade you get based on the number you turn in. So this one, we want to look at what's called compound inequalities. Interval of the reals. A finite interval is the set of all reals between 2 specified reals on a number line. Endpoints may or not be included. That's the parentheses and the bracket that we've been talking about with our interval notation. Now, the following are examples of compound inequalities. A conjunction, which we introduced yesterday, is an intersection, uses the word and, while a disjunction is a union, and it uses the word or. Okay, and there is one typo here. That should be 5x and not 5c. Okay, they have to be the same variable. If they're not, well, then we're not going to be able to do anything with it. But let's go ahead and take a look at number 1. Let's go ahead and solve the inequalities. Okay, so 5x minus 3 is greater than 2. Now, if it's just a simple 2-step equation or inequality, I'm really going to encourage you to try to do that, in your head, because I think that's what makes you stronger. If anybody would like me to go ahead and show steps, please don't hesitate to say something. So what's the first one? X should be what? Okay, just equal to 1? Greater than 1. There we go. And then I add 3 divided by 5, so x is what? Less than or equal to 11/5. Now, what's this symbol right here? That's the intersection. Okay, we want to take the conjunction, as we just previously saw. All right, now I want you to go ahead and write your answers in different ways. We're going to write it graphically, we're going to write it in interval notation, and we're going to write it as a solution set. I think it's really important that you see all the different ways that these can be shown. Now, I like to go ahead and start with just a simple line graph. Okay, and a lot of people are going to do these visually. It's completely up to you. I think this is a great way to do it. I'm going to put my points of interest here. So we have the 1, we have the 11/5, but I don't mark on the line graph itself. I'm going to mark these separately, because do you notice anything about numbers 1 and 2? Are they the same? Okay. But are they very different? Okay. They are virtually the same problem. It's just what I'm asking you to do with it. Okay, so that's what's going to give you different answers. The problem's going to be set up the same way. All right, so we'll get there in just a second. That's why I have this over to the side that I can refer to it. Well, you'll notice the first one, we have everything greater than 1, but not including it. So above 1, I'm going to put my open circle. and I would shade to the right. I want everything larger than 1. Okay. Now for the other one, I want everything less than and including 11/5. So close circle, and I'm going to go ahead and shade to the left. So you guys told me that was the intersection. What does that mean? Does that mean I'm looking for a combination, the marriage, or am I looking for what they share? What they share, and this is why I start graphically, because you could easily see the overlap. Okay, so I'm going to start for number 1. I'm going to go ahead and draw my line graph, and this is the one I'm going to actually shade in. So I'm going to put the 1 here. I'm going to put the 11/5 here. Well, you can see the overlap exists between 1 and 11/5. So I'm going to go ahead and shade in between them. Which ones do I include, not include? How would I do that? What would you say for 1? Okay. So you're saying we don't include it. That's correct. Okay. What about the 11/5? Okay, there you go. So that would be a closed circle. So that's how I would show that answer graphically. Okay, the shaded region is going to be all the values that make this a true statement. Okay, well now I want to go ahead and show this as an interval notation. This is where the parentheses and the bracket come in. What would that be? Okay, so that's what Satish said. Is he right? Yeah, and when you're putting these answers right next to each other, you should notice that they're going to mimic each other because they're giving you the same information. Okay. And now third, I want you to also be able to express that if I ask you as a solution set. Now these are those definitions that we were talking about yesterday. Oop, move. There we go. So this is all x. What's that mean? Such that, and this is where you're going to go ahead and typically write your restriction using the inequalities. Okay, now this one right here, because we have a greater than and a less than, we can actually combine those into a compound inequality. So I can go ahead and say 1 is less than x, which is less than or equal to 11/5. Okay, see, I'm still making the same statement. X is greater than 1, but less than or equal to 11/5. Okay. Questions? Did anybody have one of those written? Probably the interval notation is what I would guess. How many people had that number 1 good to go? Okay, so a few folks. Okay. Now let's go ahead and take a look at example 2. I still have the same 2 sets. X is greater than 1. X is less than or equal to 11/5. But this time I'm taking the what? The union. Okay. So I'm not interested in what they share. I'm taking everything. So how am I going to show that graphically? Where would I shade? All of it. Okay. If I'm going to take everything from both sets, I'm going to go ahead and shade the entire thing. Now, I do have one question, though. This is bugging me. We didn't include 1 in the other one, so I know 1 isn't included for that first set. So how can I go ahead and shade the whole thing?
Because 1's included in the other one.
Because 1 is included in the other set. Yes, very good. Okay. How would I show that as interval notation? 2 parentheses. There we go. So negative to positive infinity. And this would probably be the one, exception. If I ask for interval notation and it is something like this, if you were to put all reals, I'm okay. That's equivalent. Okay. That's perfectly fine. Otherwise, use parentheses, brackets, comma. Okay. Now let's go ahead and write it as a solution set. So I'm going to say all x. And what can I use instead of a colon? Okay, Aiden's drawn a little vertical segment. There we go. And we know it's all reals, so why don't I go ahead and put x, the symbol for the reals. Did we have a symbol that meant like belongs to or is a member of? Okay, the curvy E. There you go. All right. How are we doing? Questions? Okay. Let's go ahead and put these someplace safe. You don't want to leave them. You don't want to lose them. This is a guaranteed grade for you. So definitely keep up with them. All right. Well, we got done with the homework. let's start talking about functions. Okay. And we'll see how far we're able to get today. So this first part here, I want to read through. Hopefully this is a review, so I'm going to rely on you guys to really be telling me what these vocabulary words and terms are. So let's get started. X equals the directed distance from the blank.
Origin.
Not the origin, because we could go different directions. Let's go specific. What axis? From the y-axis, because you're traveling along the x-axis, right? Okay. Well, f of x equals the directed distance from the, x-axis. Yeah, see, this is much more specific. Okay. Now, you're not technically wrong to go ahead and say origin, but it's just not specific enough because you have, multiple ways you could go. Okay. The blank is a visual way to determine if a curve is the graph of a function or not. The vertical line test. There we go. We talked about that the other day. Vertical line test. Okay. Now, a set of points in a coordinate plane is the graph of y as a function of x if and only if no vertical line intersects the graph at more than 1 point. So it's saying it is a function if it doesn't intersect at more than 1 point at a time. If at any time it does intersect at 2 or more points, well, then it's not going to be a function. You got x's that repeat. Okay. All right. Now, these next three, they are related to each other. Okay. They come from the same topic. So a function f is blank on an interval if for any two x values in the interval where x sub 1 is less than x sub 2, we have f of x sub 1 less than f of x sub 2. Okay, what do you guys think? Oh, what was that? Somebody said something. Aiden, you say increasing? Perfect. Yes. Let's kind of visualize what's happening here. Let me go ahead and just draw a quick x and y system. Now, we have some values of x, and all I know is that the first one is smaller than the second, right? So let's say this is x1, this is x2. Well, what does f of x represent? That's the y value, right? That's an element in your range. So if I were to plug in a specific x, I get a specific corresponding y value to accompany it. So what I'm told is for whatever x does in the function, this y value is going to be less than whatever the function does to the x value over here. So it's going to be just a larger one. Yeah. So we can see it's increasing. The y values are getting larger. Okay. So the next one, a function f is blank on an interval if for any two x values in the interval, we still have the first x less than the second, but now we have f of x sub 1 greater than f of x sub 2. Now this is decreasing. Very good. Okay. And then a function f is blank on an interval if for any two x values we have f of x1 equals f of x sub 2. So it's horizontal. Did someone say it? Starts with a C. Constant. There we go. And this is a topic that we'll get to probably tomorrow. Remember, we are going to have the quiz. So that's going to take probably 10, 15 minutes in class time. All right. But, depending on your function, maybe your function strictly increases, strictly decreases. It could very well do both. When you start getting to piecewise functions that we'll talk about on Friday, it could do all three. Okay, so we'll just have to see. But the idea is you look for where the y values are getting larger or getting smaller. That's what we call increasing and decreasing. And we label those using the x-axis. Okay, we have intervals for that. All right, we're almost done with the vocabulary. So a function f is blank if for each x in the domain of f, f of negative x equals f of x. So you may or may not have done this in Algebra 2. Aiden, you think you know it again? What's that? Even. That is absolutely correct. Bless you. Okay. So what this means is if I can take a function, if I can go ahead and plug in every x, replace it with a negative x, and I simplify, if I get the original function, that guarantees me it's even. Okay, so let's just choose an easy one. Let's say f of x equals x squared, the quadratic parent. Okay, so if I were to replace x with its opposite, so f of negative x equals negative x squared. Well, what happens when you square a negative? Yeah, it's still, well, positive, which makes it even. There you go. So you see how I got back to the exact graph? That's what makes it even. Okay, the fact that you got the exact same equation. Now, think about x squared, the parent. This will help you with the next part. The graph of the function will display symmetry about the y-axis. There you go. Good, good, good. So if a graph is symmetric with the y-axis, if I can fold it and the two parts come together perfectly, we say they coincide. You know, it's what you should do when it rains. Coincide. Go inside, coincide. Yeah. Okay. Okay, next. Function f is blank if for each x in the domain of f, f of negative x equals negative f of x. So this one's got to be odd. There we go. Okay, so let me give you an example. F of x equals, let's look at the cubic parent. Okay. So it's the same idea if I can replace every x with its opposite, but this time if I get the opposite function. Every term has now changed sign. Then it's going to have a specific symmetry, and we call it odd. Well, let's see. F of negative x equals negative x cubed. Well, what's a negative times a negative times a negative? It's still a negative, right? So this would be negative x cubed. You see how I got the direct opposite as far as sign goes from what I started with? That's what we call odd. So does anybody remember what x cubed looks like? Can anybody like draw it in the air for me? Raphael? There you go. Okay, so let me go ahead and sketch it very quickly here. So curves up through the origin like that. So the graph of the function will display symmetry about, now with the x-axis, the origin. So let's imagine that that origin was the one fixed point like a fan blade. If you can take the graph, if you can rotate it 180 degrees, just half a revolution, if you end up with the exact same graph, that's symmetric about the origin. So if I were to take this guy here and just rotate him, yeah, I'm going to end up with the exact same thing. Okay. Good, good, good. Does a lot of that kind of seem familiar? How many people saw even and odd functions in Algebra 2? It depends on your teacher. Some did, some didn't, okay? Increasing, decreasing, constant? Not so much. Okay, so that's fine. See, that's why we're doing this, so we can go ahead and fill in those gaps. Okay, let's go ahead and take a look here. Let's start looking at domain and range. Okay, now what am I talking about when I say domain and range? Bless you. Okay, what's domain? Yeah, it's all the x values. Every x value that has a part in the graph. So the range is all the y values, okay? What were the vocabulary words we looked at early in the week? Okay, abscissas and ordinates. Which was which? Abscissas are the x, ordinates are the y. Very good. Okay, well, really when you're asked for domain and range, you're being asked how much space does your graph occupy in the plane? So basically how wide and how tall. Okay, so maybe it goes forever, maybe it has specific boundaries. Okay, how wide is this guy? He definitely doesn't go forever, so where does he start? Okay, so he begins at -2, and where does he stop? 4. So -2 to 4. See, that's as wide as he is. He doesn't exist outside of that interval. How am I going to close it up? Parentheses and a bracket. Now, what about that -2 tells you he's not included? The open circle. Now, here's a good question. Let's say you had the exact same curve. But there's only one difference. The other endpoint does not show you an open circle. Do you still? Could be, but here there's no other branch, so it would probably be more accurate to say removable discontinuity than a jump discontinuity. But that's good that you knew about that. We're actually going to be talking about those in a couple weeks. So let's say it just stops. Here's the question. Do I still include it or do I not include it? What do you guys think? How many people think, yes, I would include it? How many people think, no, I'm not going to include it? How many people are not going to vote? If it just stops, you have to include it. There has to be something telling you for some reason that it's not going to be included. So that's why that removable discontinuity is going to be really important. Okay. All right. Now we have some function notation. So we don't know what the actual equation is, and we don't need it because we see the graph. So all we're doing is evaluating the function at specific values of x. That's what's in your parentheses. Okay. So what's the first x I want? 0. Okay. So again, I'm not going to insult anybody's intelligence. I'm sure everybody knows how to do this, but just to walk through the process, I'm going to find 0 on the x-axis. That's what I'm interested in. What's the y value that corresponds to that 0? Yeah, because the graph is below. When x is 0, I have this point right here, -3. So f of 0 is -3. Remember, because the function notation is the range. That's the y value. What's in parentheses is your domain in x. Okay. So we do the same thing over here. F of 2. There you go. When x is 2, the graph is below, so I go straight down. I'm looking for the y value that corresponds. So f of 2 is -5, so that I have 2 -5. Okay. And then what's the last one here? F of 4. -3. There we go. Perfect. What is the range? How tall is it? Okay, so I heard -5 to what? -5 to 3. That's as tall as he is. No y value goes higher or lower than those. So -5 to 3, how do I close it? Include the -5. Not include the 3 for the same reason we didn't include the -2. It has the open circle there. Okay. Everybody doing all right? Okay. No problems? Okay. We could say we function well in our domain. You get that one? Okay. Let's make sure. Yeah. Cool. All right. Well, let's move on. All right. So now I want to go ahead and just work with what we refer to as implicit and explicit equations. Can anybody tell me the difference? Did this ever come up when you were in Algebra 2? Okay, that's fine. Now, these are what we call implicit equations. Okay, it says go ahead and find the explicit form and use a graphing utility. We're not going to worry about a calculator because we don't need one. We can do it without a calculator. Okay, hopefully. But it has to do with the dependent variable. Okay, if you're able to rewrite the function so that you have, in this case, y as a function of x, okay, that's what we're talking about as explicit. Okay, because if y is the dependent, that means x is the what? That's the independent. For any value of x I choose, once I plug that into the function, I have a specific value of y that's going to correspond to it. That's why we say y is a function of x. Okay, so I want to rewrite this solving for the dependent variable. Does that make sense? That's really all it comes down to. All right, now these again, if anybody wants me to go ahead and take steps, please let me know. Otherwise, we're just going to go straight to the explicit equation. This would be y equals what? Satish, what you saying? 1/2 x squared. Perfect. 1/2 x squared plus 2. Okay, what do you guys think? Now, here's one of those things, and I really want to emphasize this. I know, especially in mathematics, it can be intimidating from time to time. Has anybody ever been in the situation where it's a large class, maybe like this one, you wanted to ask a question, but you were like, I don't want people to think it's a dumb question or anything, so I'm not going to ask the question. Has anybody ever been in that situation? Okay. Probably a lot of people in here have been, okay? If you have a question, please ask. If you want me to show you something, tell me, hey, show me how you got that, okay? Because if you don't ask, I can't help you, right? Okay. All right, so everybody's okay how we got 1/2 x squared plus 2? All right, so let's go ahead and graph it. Well, this is definitely a parabola, okay? What will the plus 2 do? This is where you got to think back to your transformations. Ooh, it is a shift, but it won't go left. Ooh, it's not horizontal. It's vertical. There we go. So this is going to move it up. Okay. So we have the parent starting at 0, 0. So everything's going to be shifted up 2. So that's where the vertex is. What's the 1/2 going to do? This is a dilation. Is this vertical or is this horizontal? This is vertical. Okay. So is it going to stretch it or shrink it? It's going to shrink it. The y values will be half of what they originally were. So what effect will that have on the parabola? Imagine I had the parabola in my hand and I just crushed it. There you go. Stephanie says it's going to make it wider. Now, we're not looking for an exact graph. Okay. If we wanted an exact graph, we'd go ahead and create a table, or we'd go ahead and use technology. These are just sketches. Okay. Yes. Not during lessons. Sorry. Unless you're about to explode, I don't, or you're vomiting or something, we got to wait. It's kind of full. And see, that's the problem, because then everything turns into an emergency. I give you one, but you got to go during passing periods. Okay, because we might cover material that you don't know about when you're gone. So I'd say you're in luck today. Well, actually, that was kind of a joke. I said you're in luck. I'd make another joke, but it'd be pretty crappy. Okay, so the pass is right there. Okay, be in good health. Okay. All right, so we got our graph here, and there we go. Is this a function? Yes, it'll definitely pass the vertical line test. Now, what was it the other day we brought up? Even if it's not a function, we can always refer to it as a what? It's a collection of points. Starts with an R. Relation. Everything is always a relation, but it may or may not be a function. This one is. Okay, so I still want to go ahead and practice domain and range, even though it doesn't say it, because that's definitely something that you're going to be expected to do. All right, so let's say Jane, correct? Okay, what would you say the domain of this is? How wide is the graph? There you go. He's infinitely wide. So negative to positive infinity. And I probably mentioned this, but I'm going to go ahead and mention it again. This is one of those times, if I ask you for interval notation, but this happens to be the answer, and you put all reals, that's fine. It's equivalent. I'm okay with that. All right. Let's see here. Is it Ariana? Yes? Okay. So what would you say is the range? How tall? I'm sorry? So she says infinity to 2. There we go. For your interval notation, you always go from, okay, I like it south to north, your smallest to your greatest. So her values are right. She just had those switched. How do I close that? Okay, we are definitely including the 2, but we never include infinity. Doesn't matter positive or negative. We never include it. Okay, good. Let's take a look at B. So x minus y squared equals 1. Is this one where we want to take it step by step? Or can someone so we want to take it step by step. Good. Someone's actually said that. Yes. Okay. So I'm going to subtract the x over. So negative y squared equals negative x plus 1. Would everybody agree so far? Okay. Now, I'm not going to go ahead and worry. Usually, if I need to change the sign, I'm just going to go ahead and do that directly. So I need to make this negative y squared a positive. So if I change the sign of one, that just means I got to change the sign of the others. That also helps me not have to write it again. Okay. Now, what's the inverse of a square? A square root. Okay. So I got to take the square root of both sides. So y is equal to square root x minus 1. Am I missing anything? I am missing something. Stephanie? No. Those are separate. They're not multiplied. Plus or minus. When you're solving algebraically and you're simplifying an even root, you got to put plus and minus on there. Okay. So now we're dealing with the radical parents. What does the radical parent look like? Okay, so I see a lot of people showing it in the air. It starts at 0, 0, and it just curves over to the right like that. So what is the minus 1 going to do? What type of shift is this? Oh, wait a minute, why to the right? It says minus. There you go. Adding or subtracting 2x directly is a horizontal shift, but you have to take the opposite. Okay, so because it says minus, I'm just going to take this graph, and I'm going to move him 1 over. Okay, now what's the negative going to do in the plus minus? The negative has one job. Starts with an R. He's a reflection. That's why we have to have both the positive and the negative. Here's the positive square root of x minus 1. So this one would be the negative square root of x minus 1. I would just take him and flip him over. Is everybody okay with that? Okay. Now, here's the thing. When we're talking about inverses, we really, really want our inverses to be functions. So I would have to restrict this guy's domain and or range in order to make that happen. But I'm not interested in that right now. Based on what we see, is it a function? No, that's definitely going to fail the vertical line test. Okay. Not a function. I don't know why I wrote function, not a. Okay. But it is a relation, it's just not a function. Okay. Take about 10 seconds, write down what you believe the domain and range would look like in interval notation. This is third period, so we get out at 52. Is that right? Okay. Okay. So here's what we should have written for domain. He exists from 1 to infinity. And he is infinitely tall. All reals. Now remember, this is the one time I said, if it is negative to positive infinity, all reals is just as good, perfectly fine. So if you did put negative to positive infinity, that is perfect. Okay, how we doing? Is a lot of this coming back from Algebra 2? Yeah? Okay. All right, well, here's our last one today. X squared equals 2xy plus 1. Is this another one we want to take it one step at a time? Okay. So let's see what we end up with. First, I want to isolate the 2xy. So I'm going to subtract the 1. So x squared minus 1 equals 2xy. Now we want to solve for y, so I'm going to do what? Okay, divide by 2x. Okay, so those cancel. There we go. X squared minus 1 divided by 2x. What kind of graph is this? Starts with an R. This is rational, yes. This is a rational function. Okay, so we're going to be getting into these starting next week. We're going to be getting into them in a lot more detail. This one, I'm just going to be kind of scratching the surface. What's one thing that's always associated with rational functions? And it starts with an A. Asymptotes. Where is this guy's asymptotes? Stavion? Negative 1? No, I'll tell you, he has an intercept at negative 1, Where would he have his only vertical asymptote? How do I find it? Raphael? Why 0? There you go. Any value of x that makes the denominator 0, that's going to be a vertical asymptote. Now, there is an exception that will also give you the removable discontinuities, but we'll get there. So he does have an asymptote right here, x equals 0. Now, he has another asymptote, but we have to decide which. Will this function have a horizontal asymptote? I just put ha for that, okay? Or will there be an oblique? What am I referring to when I say oblique? Slant asymptote. Very good. Remember, didn't we? I think this was the one class last week we actually talked about that, right? Okay. Dylan, help me out. Horizontal or oblique? Okay. Well, if it's not horizontal, oblique. There we go. That's what I was fishing for. Now, how do we know there would be an oblique and not a horizontal? Remember, what did we look at? Started with the D?
Degree.
The degrees. The degree of the numerator is larger than the degree of the denominator. So I would use division to help me out. Now, I'm not worried about it right now. If you were to go ahead and do it, you're going to get 1/2 x. Okay. And I believe on the notes online, I did go ahead and show that division. You know, it's very simple, but if anybody wanted to take a look at it, we're just about out of time. And let's talk about my intercepts, because we definitely don't have a y-intercept. But how would I find my x-intercepts? There's something I set to 0. Starts with an n. The numerator, any value of x that makes the numerator 0, those are going to be your x-intercepts. So x squared minus 1 equals 0. X squared equals 1. So what does x equal? Ooh. Remember, we're solving it plus or minus. There we go. Plus or minus 1. So remember, Savion a moment ago said -1, and I said that was going to be one of our intercepts. Well, you can tell just by where those intercepts fall with respect to the asymptotes, you know where your branches have to go. So I'm going to have 1 right here, and I'm going to have 1 right here. Okay. So here's my question. Yes or no? Function. Yes, this is definitely a function. Okay. It gets a little iffy the closer you get to 0, but you have to think we are getting infinitely closer to 0, but we're never going to touch it. Okay, so we are not going to hit this graph in 2 places at any time. Now, here's what I want you to do for tomorrow. You don't have another homework assignment just yet. I know everybody's pretty bummed about that, but I want you to take not even 30 seconds. You probably even do it before you leave today. And don't say it out loud. This is where we're going to start tomorrow. I want you to tell me the domain and range of this guy in interval notation. That's where we'll start tomorrow, and then we'll go on with the rest of the packet. With any luck, even with the quiz, we should finish. If we have to continue Friday, so be it. Okay? All right, how we doing? Don't forget about the quiz tomorrow over intersection union complements. Test next week over everything. Guys, thank you very much. Another great